This is a presentation of Human-Centered Security Team Y. The student numbers are 2358950,
2358806,
2358944,
2395142X.
The presentation aims to show our development of a security support application for elderly mobile users based on Android platform. It includes the introduction, background, implementation, evaluation, discussion, and the conclusion. After the fast development of technology in current community, the percentage of elderly users of smartphones have increased in a large extent. It is a contentious issue that the elderly users are immature according to the operations of smartphones because of the decreasing study abilities. They have no choices but to request the help from trusted individuals such as younger family members when performing complex tasks such as the security configuration. However, another prominent problem appears that the system of smartphones are designed for single users. Therefore, it is nearly impossible for elderly users to achieve external support directly from remote trusted individuals. Regarding to this problem, we have designed a security support application that supports the communications between elderly users and trusted individuals regarding to the security settings on mobile devices. It allows elderly users request help from trusted individuals and receive the corresponding assistances, where the assistances include the suggestions generated by the current configuration of helpers' devices and the remote operations from helpers.
In the literature review, we will discuss the 4 parts of the project, the technical parts, including pull and push mode, implicit and explicit mode, interface usability, and the defense of side channel attacks. About the pull and push mode, experts have designed several interfaces and environments for the web and the system. In 2009, Connor introduced a FRP about the push and pull mode. The statistics and driven demand introduced by this article inspired our design. In 2011, Jehani moved forward to design an environment for the web users in multi-device environments. This article's description about the mobile device simply helped us to design the mode required. The research from Michaelis introduced the explicit and implicit ratings about the mobile applications. The contents about the explicit and implicit design helped the research group to improve this part. While talking about the considerations to the usability about the design and the evaluation, the recommended article about 10 usability heuristics for interface design is the most important reference the research focus. Some other standards for the usability are also referred. The design using human-computer interaction theories refer the articles mainly written by Professor Chalmers, also the lecturer of HCI at last semester. While this project needs security enhancements to defend the potential side channel attacks, the file referred is the slides introduce the attack based on machine learning, though it is complicated but help the team to be aware of the data attack and about the method. The article referred is written by Wu.
This is implementation. First, open the app and go to the main page. Click Start to become a floating window. Click on the floating window while using. Open the large floating window. Click on Screenshot and ask if older people want to send a screenshot and ask for help. Click Yes to open the chart interface. Go back to the previous page. Click Recommend. Open the recommend page that the security spotter have given to the other people. Go back to the private page. Click on Setting from Others. Open the Setting from Other page. Here you can see the setting of security spotter set on this app. When input a password, such as the payment page, the keyboard will be random and show a warning. Here we look the security spotter screen. The arrow around the avatar can select the old people of the server. Click Help to send a message to the client to ask, does old people need help? If the old people select yes, please, it will open the chart interface. Go back to the main page. Click on Recommend. Enter the recommend page. Here, security spotters can choose the suggestions give to the old people. Go back to the main page. Click on Setting Advice. Here, the security spotters can choose to display the setting for different apps on the client. Go back to the main page. Click Update Advice. Enter the Update Advice page. Here, security spotters can recommend older people to update the app.
Since the prototype has been successfully implemented, the evaluation should be carried out to focus on the goal to evaluate the usability of the implemented prototype, as well as the security against side channel attacks. The side channel attacks will specify to shoulder suffering in this user study. We hypothesize that the prototype will perform well against the shoulder suffering attack with, of course, a good reflection on usability. We set a threat mode to simulate the best condition for attackers to grab personal information from the users. Variables for the user study. The dependent variables are error rate for supporters and supported users, and accuracy for attackers. The procedure is when all our participants were in place, we will explain the study and assign roles for the participants. There were 18 participants, which are all students from Glasgow University, aged from 23 to 26, and they were divided into 6 groups. Each group had an elder, acted by a participant, and a supporter, and an attacker. The 6 groups will be divided into 2 groups. One is the baseline, and the other is a security implemented group.
When the experiment begins, all the participants will be given time to view the prototype. There are several instructions need to be operated for the supporter and the user. Instructions required are for elderly taking a screenshot and ask for help with the recommended setting, cite PIN and input once more. For supporters, answering the help request, pushes necessary information, recommend citing, and for attackers is observing the elderly. So the result is, of our experiment indicates that our prototype performs well in terms of usability. There were no errors were made during the experiment, and only 3 of 12 elderly and supporters slowed down their process when operating, and 2 of them seems to due to the security approaches. So it means the approaches we implemented has some negative impact on usability. As for questionnaires, the participants hold a positive attitude towards our implication. Although from question 3 and question 4 and question 5, the negative feedback indicates that it's not that friendly for elders. But since the participants were not real elderly, so it may result in different situation for real scenario. And for question 5, it is not surprisingly, as this is a handprint prototype. That's all for the evaluation.
From the evaluation, this system successfully completed the requirements of the project. So here we do some discussions of our work. Through the design phase, the major problem we encountered is the method to support the elderly to recognize the different patterns and achieve real support from this system. Through the design period, by using the theories of the HCI, the method to design the size and the color of buttons can simply help the elderly, and the using of the push and the explicit mode can let the elderly recognize the support they can get. This is a discussion about the usability. And the other problem is avoid the side channel attack. This is a security problem. By using the methods learned from lectures, part of the threats can be avoided at last. But about the attacks like using heat monitoring or other methods that using technologies to get information to steal, there are still works to do in the future. About the future works, UI design is the main focus on the future works. The research team will focus on the UI design to move forward to improve the usability of the system. Operations will be simplified to reduce the learning process for the elderly. More recognition methods can be inputted to fulfill these drawbacks, like using distance recognition to ensure the information is being sent securely to the supporter. In the evaluation, the research team invited students to try on the prototype, but with no old people, and the amount is relatively low. These results can be different if there is a massive people try on this system. In all, more improvements with usability and security, along with better evaluation, will be conducted. In all, for the conclusion, we can clearly say that this system designed by the research team fulfilled the requirements of the project. It starts from two visions of the user and the supporter. Similar interfaces can ensure the usability. Encryption technology and the concealment of the content can ensure the security. These methods can avoid the side channel attacks, just part of them, but we will do better in the future. The system is a combination of the push mode and the implicit and explicit mode. This simply helps the users to choose his preferences. The evaluation part shows the feasibility and the acceptance of the design system. Also, the drawbacks are pointed out and discussed in the future works part. From this project, the research team used theories of HCI and combined the theories with the knowledge comes from human-centered security. There will still be work discussed and improved by the team. This is the end of the presentation. Thank you for watching.